Welcome to the technical summary for Commvault Platform Release 2023, where we will highlight several key enhancements in this release. Please take a moment to read the on-screen disclaimer. Some of the features discussed in this module are opt-in through the Early Adopter program. They require an auth code to use, which will be provided once the customer has requested access through Early Adopter at commvault.com and met the requirements outlined in the Early Adopter program. In this technical summary for Platform Release 2023, we're focusing on new enterprise hybrid cloud data protection through our Data Protection Intelligence service, including new features for Amazon, Azure, Google Cloud, Oracle Cloud Infrastructure, and Hadoop backup optimization. New data security features includes threat analysis enhancements, deeper SIM integration, and compliance and storage lock functionality. Also, full service protection for Azure DevOps and Amazon FSx NetApp, helping to enable application modernization as part of our Data Transformation Intelligent Data Service. Let's talk about the data protection enhancements in more detail. AWS Virtual Private Cloud Protection allows customers to simplify and accelerate the recovery of their Amazon VPC instances along with any deleted VPC resources. The idea behind Amazon VPC protection is that an Amazon EC2 backup will 1. Protect VPC resources related to protected Amazon EC2 instances, 2. Allow recovery of VPC resources when performing an in-place Amazon EC2 restore, 3. Recover the instance and VPC configuration as one Commvault automated or orchestrated operation, and 4. Allow forensic investigation of suspected changes to security configurations. AWS VPC protection is part of the Early Adopter program and requires an auth code to use, which will be provided once the customer has requested access through Early Adopter at commvault.com and met the requirements outlined in the Early Adopter program. So how does it all work? We start with Commvault sitting inside a shared backup account, and we use IAM policies attached to identities to get access to the environment. We do that by having one or many customer or tenant accounts, and this is where all the workloads live. We request temporary credentials using STS assume role. This is done by using auto-scaling access nodes that are deployed per region and used to make the request to gain access and discover the EC2 instances and their network configuration. The nodes query a service endpoint to discover and forward VPC configuration to the admin account. And then we collect the data and drop it into an S3 bucket and then reverse that process for the restore. Let's now take a look at this in a demonstration. Protecting your VPC is critical to recovering from ransomware, malware, or bad actor events. In fact, recovery of a known good network state is key to resuming service from bad changes too. We have two accounts configured, a central backup admin and a member account. Shared data management resources and backups are stored in the central account. Our Amazon EC2 instances and protected VPC resources reside in the member account. Commvault uses STS assume role to request temporary credentials to protect the member account resources. We have both production and non-production resources protected. You should consider segregating your environments into separate AWS accounts. Commvault automatically discovers instances to protect using AWS tags at backup time. Let's run a restore for our non-production instances. Amazon VPC protection has added a new restore type. You can restore your instance configuration files, which includes all Amazon VPC resource configurations in JSON format. You can also restore your Amazon EC2 instance along with VPCs, subnets, and security groups. Let's restore our instance configuration from a service-independent backup copy, you can restore to any Commvault client with the file system agent installed. Network configuration details can be reviewed for security incident investigation and failed change reviews. Details on the instance VPC, subnets, network interfaces, security groups, and many others are recorded. Commvault uses this information to recover or recreate some resources during restore. Let's delete our EC2 instances and VPCs to simulate a data loss event or misconfiguration. Let's now run a full EC2 instance restore. We will restore in place and recover dependent Amazon VPC resources. When complete, our EC2 instance will be powered on. We will select Amazon EBS Direct APIs for restore. This is the default. Commvault begins by restoring each EC2 instance volume as an EBS snapshot, which you can see at the bottom. The progress column shows the progress of volume recovery. Once the EBS snapshots are completed, EBS volumes may be provisioned for the EC2 instance. Commvault will then recreate missing VPCs, subnets, security groups, and network interfaces. We can now see our VPC has been recreated. Our subnets used by the EC2 instance are recreated. Default routes are populated on VPC creation. A default network ACL is created with the VPC. It's not restored from backup. Our instance is in the final stages of recovery. We can review the restored EC2 instance. AWS resource tags have been restored. The Network tab shows the restored VPC, subnet, and network interface and security group. Our EC2 instance and related VPC resources are restored. For Microsoft Azure, we're adding a few new capabilities. At the top of the list is Azure Restore Points, where we're the first Microsoft partner to develop this capability through a Microsoft-provided API. Customers need application consistency as production landscapes grow in Azure. This has been historically accomplished through scripting. With Azure Restore Points, we're able to provide application consistency, including easier and more complete recoverability, reducing costs by utilizing lower cost storage for restore point collections, and lowering the risk of data loss. Microsoft Azure Restore Points are unique to Commvault. This not only demonstrates our close relationship and partnership with Microsoft, but our deep cloud integration, going beyond just basic snaps like our competitors are limited to. Let's now take a look at this in a demonstration. We'll start off in the Azure portal. We'll take a look in my CV Backup resource group and we'll drill into a test client I have already configured. Pay attention to the tags defined and that it's recently been backed up. Now let's go to Command Center. We'll quickly configure an Azure hypervisor. We'll give it a name. We'll also configure it to use managed identities. This is perfect for zero trust policies. Select an access node and hit Next. Next, we create a VM group. Give it a name. We'll define some rules for this group, so it will use tag names and values. In this case, we'll use the CV test backup tag we saw earlier, and the value of true. This means these rules will be dynamic. So as new instances are created with these tags, they will also be protected by this VM group. Next, we'll select a plan, and then hit Finish. We'll need to adjust our created VM group to support Azure groups. Go to Settings, click Edit, and choose File System and Application Consistent. You'll get a warning that the next backup will be converted to full. One last change will be to pull the snaps into a central resource group, which is good for billing and reporting. Now we'll run a backup. We'll speed things up a little until the job completes. Now, in the Azure portal, let's check the instance. We can see the backup is complete. Now let's look at our restore points. Inside the restore point, you can see the instance name, region, and the hex ID of the subclient. If we look at the command center, the job ID of the job that just completed will correspond to the ID of the restore point. For Google Cloud, we're introducing new GCP regional snapshots to help customers better manage security and lower costs. For context, prior to October 1st, 2022, GCP pricing for regional and multi-regional snapshots was the same. But after that date, multi-regional snapshots increased in cost by a larger amount than regional snapshots. So the introduction of regional snapshots now provides a potential cost savings of up to 30% versus multi-regional snapshots. In addition, regional snapshots also allow customers to keep their snapshots within the same region, allowing customers who need to satisfy potential security and regulatory needs. Regions are geographical locations with 3 or more zones in each region. A snapshot will live in the region where the VM instance persistent disk resides. Using a single regional snapshot lends more control over the physical location of your data. Multi-region is an entity that represents a large area such as the United States or Asia. A snapshot will live in the multi-region area, for example US, Asia or EU, where the VM instance persistent disk resides. Using a multi-regional snapshot replicates the snapshot across multiple regions for redundancy. Let's now take a look at this in a demonstration. We'll start from Command Center, where we have a hypervisor and VM group created to protect our GCP VMs. We'll look at the VM group configuration and can see the snapshot location is set to the default of regional. Let's go and take a backup and then take a look at the snapshot details in Azure. So now in Azure, we can see each of the snapshots going to the different regions where the persistent disks exist. Now if we go back to Command Center and edit the VM group settings so the snapshot location is set to multi-regional, on taking another backup, if we then check Azure, we see that the snapshots are all in the US multi-region. For Oracle Cloud Infrastructure, we're adding infrequent access and combined tier support. Oracle recently added support for tiered storage with their object storage offering. Previously, they used to support only standard tier. Now they added infrequent access and archive tiers in the same object storage service apart from the full archive storage service. This lets us provide parity for compute protection, enables advanced security and configurations, and also extends storage options for greater cost savings through intelligent tiering. OCI continues to be a differentiator as most competitors can only use it as a storage target. This new tiering just widens the gap for us. In addition to enhanced cloud data protection, we're also adding new support for Hadoop backups via Hadoop SnapDiff scans. This enables faster backups that use less bandwidth, including more efficient incremental backups, as well as cost savings through lower storage usage. Most of the enterprises have large multi-petabyte deployments, and our ability to do faster backups with cost savings will differentiate us from competitors. Let's have a look at how this works. Firstly, the CommServe initiates the backup. The Hadoop agent removes all but the last successful Commvault snapshot from each node in the cluster. The on-screen diagram shows a single node for illustrative purposes. The Hadoop agent triggers an HDFS snapshot on each node of the cluster. Snapshot diff then compares new and previous snapshots and lists files that are new or have changed. The Hadoop agent then scans and protects only the files listed by snapshot diff. To set up Hadoop snapshot diff, you first need to upgrade all agents in the cluster to CPR 2023. Then, optimized scan should be selected from the advanced subclient properties in the Commcell console. We will monitor usage of this feature before looking to move its configuration into Command Center. The first incremental job after selecting optimized scan will run a recursive scan, and then subsequent incremental jobs will use snapshot diff. Let us now look at some data security enhancements in more detail. New organizational personas, SecOps, ITOps, and service providers do not work within the Commvault Command Center and use purpose-driven tools to manage events in an automated way. Automation is driven through external SIEM and event manager platforms based on triggered events collected for streamlined operation. Interoperability with event management systems, especially security platforms, is crucial for establishing stickiness and extrinsic value for the Commvault platform. We've added deeper SIEM integration and greater interoperability with external security platforms, including easily allowing exporting of datasets across platforms via frameworks using standard protocols and APIs. Broad support for virtually any SIEM or event management platform. And the SIEM connector, so you can stream alerts, audit information and events to a third-party SIEM or event management system using webhooks. The SIEM connector is an event streaming policy. It defines what to collect and where to send it. The SIEM collector receives alert, audit trail and event notifications from the CommServe and transmits them to a third-party application such as Splunk, Teams and Syslog. We support two types of connector. Webhook is the modern approach to sending event data to another system. It uses REST API to send data in JSON format over HTTPS. Syslog is the classic standard for sending messages to another system. It sends data in the Syslog format using a UDP or TCP connector. Let's take a look at this in a demonstration. We'll start in Command Center, but in this case in Metallic, demonstrating this feature works on both platforms. So expand Manage and select System, and then click the Webhook tile to configure Webhook. In the upper right corner, click Add. Give it a name, and paste the Webhook URL, which has the authentication token at the end. No further configuration is required here, so click Add. Be aware that depending on which provider you use, you may need to do additional configuration elements here. Next, return to the System menu and click the SIM connector tile. In the upper right, click Add Connector to create the policy. Give it a name. Select the connector type, and then select the data to stream. Noting as this is metallic, only alerts and audit are available. In Commvault, events are also available. Click Next to proceed. The template is displayed and can be modified if required. Some providers like Splunk may require additional elements added. Please check the documentation for more details. Click Submit to configure. So now the connector is created and enabled. I'll go ahead and change my system by enabling encryption on some storage. This will become an entry in the audit trail. But now, if we switch to HookDeck, the webhook receiver, we can see the events being collected. If I open up these events, I can see the audit trail information. Remember that this functionality is for a persona who doesn't want to access Command Center for this information. They want it in near real time in their own tools. Compliance Lock and Worm Copy have been in the product now in some form for a number of releases, helping protect against insider threats by keeping backup data immutable and allowing organizations to remain compliant with readiness objectives and regulatory compliance requirements. With this release, these security features have been added to the Command Center to simplify configuration and usage. Compliance Lock is the new product name for Worm Copy, as previously used in the CommCell console. It is enabled on storage level in Commvault Command Center, but it is important to understand that Compliance Lock does not enable storage level worm. It is a software control where all backup destinations using the Compliance Lock storage will be locked, preventing the following destructive tasks from being performed. On Compliance Lock storage, you cannot reduce retention on backup destinations or copies using locked storage. You cannot delete backup jobs, compliance locked storage, backup destinations or copies using locked storage, and servers or apps protected in locked storage. Worm Storage Lock configures storage level immutability controls for cloud and supported on-premise storage targets. When enabling Worm Storage Lock from the Commvault Command Center, Compliance Lock is automatically enabled so that data on storage is immutable and retention policies are locked from changes. Worm Storage Lock uses the retention as configured on the storage across all backup destinations. Existing copies will use the storage retention when using Worm Storage Lock on pre-configured copies. You should refer to documentation for a list of unsupported applications and supported vendors along with their relevant setup prerequisites. For example, with Azure, you must use IAM role-based authentication, with documented roles configured, and a container must be pre-created with version-level immutability. Similar requirements exist for AWS, with specific permissions required and pre-created storage with object lock enabled. Please refer to the documentation for more details. This is a comparison of the storage footprint for Worm Storage Lock when using bucket level and object level storage. At a high level, bucket level storage such as GCP or OCI will have a 3 times footprint, while object level such as Azure or AWS will have a 2 times footprint. The object level storage will typically be able to prune out faster as we are setting the object retention to the prune date of the stores as we're sealing them. You can see the figures on screen for each storage type. So for bucket level, if you have a 30-day retention, you will get a 30-day seal with a 60-day bucket and container retention. The dedupe store will age every 90 days. For object level, if you have a 30-day retention, you will get a 30-day seal and object level retention, with the dedupe store aging every 60 days. So what does the worm storage lock toggle actually do? For non-dedupe storage pools, it enables object lock with object retention set to the worm storage retention. For deduplicated storage pools, first it enables object lock and configures the bucket or container with 2 times worm storage retention. For AWS, it enables compliance mode. For Microsoft Azure, it enables time-based retention. Next, it sets create new DDB every X days to match the worm storage retention. Then, micro pruning is disabled and compliance lock is enabled. Let's take a look at compliance and storage lock in a short demonstration. This demo really highlights how simple it is to enable worm storage lock from Commvault Command Center. We'll start by browsing to cloud storage. Here we have some pre-configured cloud storage. Select the storage where you want to enable storage lock, and in the Configuration tab, we'll simply click the Worm Storage Lock toggle. To configure this, we select a retention period. The bottom part of the box will highlight any backup destinations that will be affected by this change. Click OK to enable Worm. A confirmation box with prompts and warnings will be displayed. Click the checkboxes, type Confirm, and then click Confirm to enable Worm Storage Lock and Compliance Lock. We've enhanced our file data and threat analysis capabilities with the ability to inspect backup content for malware to remove threats from content and perform clean recoveries. Threat analysis allows users to inspect backup content for malware using a built-in scanning engine so that customers can restore clean versions of data. File data analysis allows users to inspect backup content to identify if there are any files encrypted, corrupted, or modified in an unusual way using SIM-hash and entropy algorithms. A Windows or Linux media agent is required with the following packages: Index Store, Index Gateway. The content analyzer of the SIM and entropy hash is required for file data analysis, and for threat analysis, the malware scanning SDK is required. It's supported for file system data on Windows and Linux. And the hardware requirements shown on screen are similar to file storage optimization. File data and threat analysis is part of the early adopter program and requires an auth code to use, which will be provided once the customer has requested access through early adopter at commvault.com and met the requirements outlined in the early adopter program. The content analyzer uses 2 algorithms to inspect files. The SIM-hash algorithm is designed by Google to find similarities between 2 datasets. Multiple versions of protected files are analyzed, and if there is enough variance between versions, drastic changes could indicate the file was scrambled, encrypted, or unusually modified. The file entropy algorithm measures the level of randomness within a dataset. Multiple versions of protected files are analyzed, and if the randomness increases between versions, this could indicate encrypted files or files containing hidden data, potentially malware. Let's now take a look at this in a demonstration. We'll use a ransomware simulator to encrypt the data on our server. Once encrypted, we'll go to Command Center and take a backup, assuming this client would normally follow a backup schedule in the real world. Let's fast forward a bit, and the backup has completed. If we expand monitoring and view unusual file activity, we can see our anomaly displayed. By clicking the Actions button to the right of the anomaly, we can select to analyze the file data. Select a useful time frame to analyze, pick an index server, and then hit Analyze. This will run a data curation job that will perform the analysis. Once detected, any anomalies will be displayed as file data type in the Unusual File Activity report. By clicking the anomaly, we can then see details of the suspicious files, with a timeline and the ability to drill down into these files. By clicking a file, we can see further details. We have two files, one suspicious, one not. From the Actions menu, I can mark a suspicious file as safe or corrupt. In this demo, we'll drill into the cars folder. Within here, we can see a file encrypted.docx. Let's drill into this. This version is marked safe and opens fine. But when we then view the suspicious file, the preview cannot be displayed. If we also open the file on the client, we can see it is definitely encrypted. So in the Unusual File Activity view, let's mark this file as corrupt. This is now flagged in the index as corrupt and will not be available for restore. Now we'll go and try a recovery. We'll browse the cars folder and select the encryption.docx file to recover in place. Hit submit, and when the restore is complete, the unencrypted, safe version is recovered. So how does threat analysis work? Firstly, the latest backup cycle, both falls and incrementals, are selected for scanning. Commvault uses a built-in Avira antivirus engine that is part of the threat analysis package. Antivirus definitions are updated prior to scanning operations within a 24-hour window. Next, files are restored out of place to the index server DM2 cache, indexed, scanned, and removed after the scan completes. If malware is detected, the file is flagged in the index. An alert is sent that threats were detected and the infected files are visible on the Unusual File Activity dashboard. Infected files are automatically quarantined from the backup content and will be hidden during recovery. Let's now take a look at threat analysis in a quick demonstration. To perform threat analysis, we'll start in Command Center, where we need to create a threat analysis plan. Give the plan a name and select the index server. Then select a schedule. We'll pick daily. Next, pick the file type extensions to be restored and scanned. To scan everything, enter *** as the file extension. You can set exclude paths and file size limits. Click Save. So now you need to associate a server to the plan. This can be done from the subclient level by selecting the plan in the Threat Analysis section. Fast forward a little, and our threat analysis has been performed by schedule. Looking at the File Anomaly dashboard, we can see a threat analysis entry. By viewing the details, we can see the different malware threats found on the server. So now, if we go to do a browse and recovery, these infected files are already filtered from the view and are unable to be selected for restore. Let us now talk about data transformation features in more detail. For AWS, we're extending our deep support for NetApp AWS to bring the on-premises NetApp experience to the cloud. With this capability, we help accelerate application migration to the cloud. ensuring policy-based protection of the hybrid NetApp ONTAP data landscape using Commvault IntelliSnap. And we provide low RTO application consistent recovery for your NetApp data located on Amazon FSx. Few of our competitors support AWS FSx for NetApp. The key competitive angle is us versus cloud native. This essentially takes what we've been doing for over a decade with NetApp snapshot management via IntelliSnap and bringing it to the cloud. An FSxN instance is essentially a NetApp SVM, and each one must be registered within Array Manager. As FSxN uses our standard NetApp Snap Engine, we can talk to NetApp directly. This follows the same requirements and recommendations as traditional NetApp environments. Replication is supported for both on-premises to FSxN and also FSxN to FSxN. FSxN has CIFS, NFS and iSCSI protocols, and NDMP is not supported. The ActiveIQ Unified Manager, formerly known as OCM, is not supported. So replication configuration must use the Open Replication Framework, with any SnapVault and mirror relationships needing to be set up prior to configuration within the software. From an Array Manager perspective, users will see no differences between the configuration of FSxN or on-premise NetApp. Both the overview and configuration pages are identical between the two flavors. And finally, we're adding secure application development with complete protection for Azure DevOps services. This includes full service protection for Azure DevOps for backup admins and development teams, and includes pipelines, boards, test plans, and artifacts. Azure DevOps Backup is a differentiator. None of our competitors protect this workload. Make sure to ask our customers about how they are protecting these workloads, as it will help us to stand out against the other Azure backup options. There are several key requirements for the deployment of Azure DevOps protection. Firstly, a server that can communicate with Azure with the Cloud Apps Agent installed is required. You will need to install both the Git client application and the Git large file storage package. Then you should add the Azure DevOps application in Command Center. To add a new DevOps configuration, navigate to Product, then to DevOps, then Add App, and select Azure DevOps. Select the Azure services you want to protect. To add Azure services to an existing DevOps configuration, navigate to Protect, then DevOps, select a configured app, and then select a repository group. Edit the Azure services, and select the Azure services you want to protect. This technical summary has highlighted a number of key updates and enhancements within this platform release. There are multiple additional enhancements in this release not covered within this summary module. We recommend reviewing the documentation and the full release session video recordings for further information on all the updates in this release. Thank you for watching.